Welcome to fourth grade Unit 3, Reasoning about Multiplication and Division. Hello, fourth grade teachers. Today we are going to look at Unit 3, Reasoning about Multiplication and Division. The purpose of this video is to provide an overview of the standards, suggested pacing, and sample some instructional strategies. In this portion of the video, we are going to review the AKS and Indicators of Achievement, or IOAs, for Unit 3. The AKS is the overarching knowledge and skills that students are expected to master. The IOAs are the learning objectives that allow students to demonstrate mastery of the AKS. The AKS and IOAs may not be taught in their entirety the first time they appear on the instructional calendar. Some AKS and IOAs will appear multiple times throughout the year. In Chapter 2 of the video, we will look to see how the AKS and IOAs in this unit are paced in detail. Unit 3 has one AKS. Under the AKS, you will find the Indicators of Achievement, or IOAs. In Unit 1, students learn how to add and subtract multi-digit numbers, which was IOA 2A. In Unit 3, the focus will be IOAs 2B, 2C, 2D, which all involve multiplication or division within AKS 2MA-A2. IOA 2E will be clustered with 2D towards the end of the unit to include all operations and multi-step problems. When learning the standard, students will add, subtract, multiply, and divide numbers using a variety of strategies based on place value, part whole, and properties of operations. Multiple strategies enable students to develop fluency and transfer that understanding to related computation problems. Notice the extension IOA 2F and 2G. Extension IOAs support the differentiated needs for your students. As you can see, the word extension is bolded and in parentheses to notify that these are extensions and are specific to Gwinnett County. Please note, you will not find resources from the state of Georgia for these IOAs. As a reminder, the state coding is listed with each GCPS IOA, so you can find resources on the Georgia DOE website. Looking at IOA 2B, students solve relevant mathematical problems involving multiplicative comparisons. Students distinguish multiplicative comparison from additive comparison. A multiplicative comparison is a situation in which one quantity is multiplied by a specified number to get another quantity. Students should be able to identify and verbalize which quantity is being multiplied and which number tells how many times. Students should be given opportunities to write and identify equations and statements for multiplicative comparisons. For IOA 2C, students solve relevant mathematical problems involving the multiplication of a number with up to 4 digits by a 1-digit whole number or involving multiplication of 2-digit numbers. Students illustrate and explain their calculations using base 10 blocks, equations, partitioning, rectangular arrays, area models, and or compensation strategies for all numbers included in the learning objectives. Students develop flexibility in decomposing numbers and gain a better understanding of place value and the distributive property in multi-digit multiplication. Multiple strategies enable students to develop fluency with multiplication and transfer that understanding to division. For IOA 2D, students solve mathematical problems related to everyday life involving division of whole numbers. Students divide up to a 4-digit dividend by a 1-digit divisor using a variety of strategies based on place value and the properties of operations. Students illustrate and explain their calculations using equations, rectangular arrays, and or area models. Students demonstrate an understanding of multiplication and division and interpret whole number quotients and remainders. For IOA 2E, students use the 4 operations with whole numbers to solve authentic multi-step mathematical problems. Students represent and model problems using equations and diagrams with a variable for the unknown quantity. Problems include solutions in which remainders must be interpreted. It is essential for students to have ongoing experiences with a variety of problem contexts in which the remainder must be interpreted. Students understand that a symbol or letter can replace an unknown quantity in an equation. Students use mental computation to determine if an answer is reasonable, as well as estimation strategies, such as using compatible numbers or rounding. For extension IOA 2F and IOA 2G, the purpose of this extension IOA is for students to use their creativity, critical thinking, problem solving, and reasoning skills to determine their own way to apply the understanding of this AKS through various platforms to show the application of skills and concepts in the real world. For extension IOA 2F, students will create their own multi-step problems based in real-life situations using all 4 operations. For IOA 2G, allow students to determine how they will identify and create a product that demonstrates their understanding of the 4 operations.
In Chapter 2, we will be discussing our Unit 3 pacing. Our pacing guides are closely aligned with the state pacing to ensure we are following the expectations from the state. The pacing guide is an example intended to model how instruction of the AKS and IOAs in each unit may be facilitated. But teachers should design pacing to be responsive to the learning needs of their students. Here's the pacing guide for Quarter 2, Unit 3, Reasoning about Multiplication and Division. The suggested length for Unit 3 is 5 weeks. Unit 3 focuses on AKS 4MA A2, which is solving problems involving addition and subtraction through the 100,000s place, as well as multiplication and division of multi-digit whole numbers presented in real-life mathematical situations using part-whole strategies. We're going to scroll down and take a look at our pacing guide. The resources for each day are located on the right-hand side of the pacing guide. Resources include traditional lesson plans, task-based lessons, formative assessments, small group moves, student tasks, and any additional resources that are aligned to the learning targets for that day. The suggested instructional sequence is located on the left side of the pacing guide. The left column provides the learning progression for the AKS and IOAs, showing whether it is concrete, representational, or abstract. The bulleted list states specific learning objectives within the IOAs, as well as any suggested manipulatives. Also embedded in the pacing guide is suggested resources to use from our textbook adoption. Georgia Revealed is intended to be used as a supplemental resource. I was going to find one of those for you. Okay, here's a Georgia Reveal lesson. So Georgia Reveal is intended to be used as a supplemental resource, not your primary resource. You will find Georgia Reveal adapted lessons aligned to the intended learning objectives, as well as other resources on the pacing guide. These are just a few of the Georgia resources available to you. Please go to your employee portal to access all of the Georgia Reveal resources available for the needs of your students. Quarter 2 starts with IOA 2B. There are 6 suggested days on the pacing guide. Students will solve 3 types of multiplicative comparison situations: product unknown or unknown product, group size unknown, and the number of groups unknown. Students will engage with manipulatives as well as draw visual representations that support their thinking. A great manipulative to incorporate into concrete instruction are color tiles. Let's look at an instructional day to point out some of the resources on our pacing guide. I'm going to go back up to our first day for IOA 2B. So this day you can see is concrete representational. The learning objectives are here. We're going to be concentrating on unknown product, and there's an example of what an unknown product would look like, a situation. We're going to use manipulatives and a bar model to represent the situation. So that's that concrete connected to the representational. We're also going to represent the problem with an equation using a variable for the unknown. And you can see the suggested manipulatives are color tiles and snap cubes. We also want you to be aware that the Georgia DOE tasks, like right here under additional resources, have been linked on the pacing guide. The Georgia DOE task that we have linked on the pacing guide will open a document with multiple resources. The link provided will land on the first page of the task that corresponds with the page number noted on the pacing guide. Similar to your GCPS resources, this is a live document that could be updated by the state. So for example, this Georgia DOE task is explore multiplicative comparisons, and you can see it's page 3 through 6. So if I were to click on this link, it would open up to page 3. As you can see, we offer many resources. From these resources, please select the best ones to meet the specific differentiated needs of your students. All right, let's scroll down to the next IOA for Unit 3. So again, you had 6 days of IOA 2B. So we're going to scroll through there, and you're going to see the next IOA on the pacing guide is IOA 2C. The suggested pacing for IOA 2C is 7 days. And on the last day, we have clustered 2E to include multi-step situations involving multiplication. Another thing I'd like to point out, let me scroll down to a day that is a task-based day. So you can see this day, I want to fix that spelling right there. You can see that this day has a different header to it. So on a traditional teacher-directed day, it's going to look more like this. And like this one says, activating strategy, mini lesson and summary are included. And we have the lesson. On a task-based learning day, there is a header that lets you know that this is task-based learning. So for example, this day right here, students are going to engage in task-based learning. And the particular lesson is a formative assessment lesson. These are labeled differently to let you know that this is a task-based learning day, not a teacher-directed lesson. So now we're going to scroll down to IOA 2D. There are 8 suggested days for IOA. Those days are clustered with 2 each. When you get more to the abstract of 2D, we can see here, starting 2D, the first lesson has students explore division using base 10 blocks. So it's a concrete lesson. They're going to be exploring that. This lesson says it's a structured, inquiry-based using base 10 blocks. And one thing to point out here, sometimes there are notes here. The teach and the active engagement in this particular lesson is flipped. Moving on down, you'll see that we'll go from concrete to concrete representational. So that progression there is there for you. We've offered up some different strategies, suggested strategies you would be doing on that day. And these particular lessons would match the bullet points over here, and the task would also match. Then we're moving into representational. See that we have offered up some base 10 grid paper for you to use for that. And then when we get down to the abstract, you see that we are suggesting moving into that partial quotient strategy. And then you can see also that 2E has been clustered. And so this particular lesson is multi-step, including addition, subtraction, and division. We've also suggested the progression of the dividend. So now you can see we suggested a 3-digit dividend on this day. And that's progressing to a 4-digit dividend and so forth. And at the end of each unit, there is the suggested Unit 3 summative assessment. In Chapter 3, this portion of the video will sample specific instructional strategies that will be utilized in this unit. Please refer to the Analyzing the Standards, sometimes referred to as the ATS, for guidance on additional instructional strategies for each IOA.
Today, we're going to look at some strategies for IOA 2B. Interpret, model, and solve problems involving multiplicative comparisons. Represent the problem with an equation using a variable for the unknown. Right, so what does this IOA mean that a student must know, understand, or be able to do? Students solve relevant mathematical problems involving multiplicative comparisons with this IOA. Students will distinguish multiplicative comparison from additive comparison. A multiplicative comparison is a situation in which one quantity is multiplied by a specified number to get another quantity. Students should be able to identify and verbalize which quantity is being multiplied and which number tells how many times. Students should be given opportunities to write and identify equations and statements for multiplicative comparisons. And there are 3 types of multiplicative comparison situations that your students will solve. One is a product unknown multiplicative comparison, and that's the one we'll model today. Another type is group size unknown, and with this comparison, students may use a division equation to solve for a missing factor. Students might also encounter a number of groups unknown multiplicative comparisons. And again, they may use a division equation or find a missing factor in a multiplication equation to solve. Right. Today, we're going to begin with a problem that you see here. And we're going to show how students can demonstrate an understanding of simple multiplicative relationships by using color tiles or concrete materials. And then we'll move to pictorial representations to represent the problem. Right? So let's take a look at this problem here. Misha has 6 pencils. Jamil has 3 times as many pencils as Misha. How many pencils does Jamil have? All right, so something I notice in this problem is that there are 2 quantities being compared. We are comparing Misha's number of pencils, and Misha has 6 pencils. We're comparing what Misha has to Jamil's number of pencils. Jamil has 3 times as many pencils as Misha. So that's telling me that Jamil has a greater number of pencils than Misha. And I'm trying to figure out exactly how many pencils Jamil has. All right, so let's begin with what we know, and let's build a model of Misha and her 6 pencils. Okay, so I'm going to begin with Misha. I'm going to jot her name here. Misha has 6 pencils. So those 6 color tiles will represent Misha's 6 pencils. All right, Jamil has 3 times as many pencils as Misha. So I'm going to write Jamil. So Jamil has 3 times Misha's quantity. So I'm going to build 6 pencils for Jamil. But then Jamil has 3 times 6. So let's make another group of 6. So 2 groups of 6 would be 2 times Misha's number of pencils. And then a third group of 6 would be 3 groups or 3 times Misha's quantity. Okay. Now, thinking about a multiplicative equation or relationship for this model, I can see that I'm looking for Jamil's number of pencils. So I'm going to say J represents Jamil. And I can see that Jamil has 3 times the number of pencils as Misha, or 3 times 6. Okay, I could also write this as 6 times 3 equals J. So Misha has 6 pencils and 6 3 times, because Jamil has 3 times her amount, is Jamil's quantity. I could repeatedly add 6 3 times to find Jamil's number of pencils, but I know already that 6 times 3 or 3 times 6 is 18. So 3 groups of 6 is 18. So Jamil has 18 pencils. Misha has 6 pencils. Jamil's number of pencils is 3 times greater than Misha's number of pencils. Right? I could also show this multiplicative comparison with a pictorial model. So we could say Misha has 6 pencils and represent that with 1 box and a 6 for 6 pencils. Jamil has 3 times Misha's number of pencils. So Jamil would have 3 groups of Misha's pencils. So 3 times Misha's quantity would be 3 groups of 6. So Jamil has 3 times Misha, 3 groups of 6. Jamil has 18 pencils. Okay, so this type of model is called a bar model. We've just represented 1 box in the bar model as a group of 6. All right, so today we looked at a concrete model for multiplicative comparison, finding a product unknown, and then we modeled a bar model or pictorial model. Today, we're going to look at solving a 2-digit by 2-digit multiplication problem using an area model. Our focus today is IOA 2C. In this IOA, students solve relevant mathematical problems involving multiplication of a number with up to 4 digits by a number with 1 digit. Students also multiply 2 2-digit numbers. Students illustrate and explain their calculations using base 10 blocks, equations, partitioning, rectangular arrays, area models, and compensation strategies. Through these strategies, students develop flexibility in decomposing numbers and gain a better understanding of place value and the distributive property. Multiple strategies enable students to develop fluency with multiplication and transfer that understanding to division. All right, we're going to look at this problem today and solve this problem with an area model using base 10 blocks concretely, and then we'll move to a pictorial representation. All right, so here's our problem. There are 15 dozen cookies in the bakery. What's the total number of cookies at the bakery? So something I notice in this problem is it's telling me that there are 15 dozen cookies in the bakery. And then it's asking me to figure out the total number of cookies at the bakery. So one thing I know is that there are 12 cookies in 1 dozen. So if I have 1 dozen cookies or 1 group of 12, there will be 12 cookies. 2 dozen cookies or 2 groups of 12 will be 24 cookies, or 12 plus 12. 3 groups of 12 or 3 dozen cookies will be 12 plus 12 plus 12, which is 36 cookies. Well, in this problem, we're trying to figure out how many cookies there would be if the bakery had 15 dozen cookies or 15 groups of 12. So I have recorded an equation, 15 times 12 equals C. The C represents a variable for our unknown quantity, which is the total number of cookies. All right. Now, before I solve using this area model you see below, I want to estimate a product. The estimate will help me know about how many cookies should be at the bakery. All right. So if I estimate 12 to the nearest 10, 12 is very close to 10. So 15 times 10 would equal 150. So this estimate tells me that there should be more than 150 cookies in the solution, because I'm trying to solve 15 times 12, and 15 times 10, which is less, is 150. All right. If I estimate 15 to the nearest 10, we could estimate 15 times 12 as 20 times 10, which would equal 200. That estimate helps me know that the total number of cookies must be less than 200. Because again, I'm trying to solve 15 times 12, and I'm estimating 20, which is much more than 15 times 10. So this estimated range helps me again know that the total number of cookies must be greater than 150 and less than 200 at the bakery. All right, so now let's solve and see what the actual number of cookies is. I'm going to use an area model. So something I know about an area model is it is a rectangle shape, because I know that when I multiply the length and the width of a rectangle, I can find the total area of that rectangle, or the product. So today, we're going to name each dimension, the length and width of this rectangle, as my two factors, 15 and 12. So I'm going to go ahead and jot a 15 here and a 12 here. Now, to help make my multiplication a little bit more efficient, we're going to decompose the factors 15 and 12 by their place value. We could decompose 15 as 10 and 5 ones. So 10 and 5 is the same as 15. All right, then we can decompose 12 as 10 and 2. So 10 and 2 is the same as 12. All right, now why am I decomposing these factors? Because we're going to look very closely at how we can find smaller partial products within this whole area. All right. Now, let's go ahead over here and let's write our equation again. So let's kind of recap here. So we have 15 times 12 equals C, the total number of cookies. Okay. And I'm looking at my model, and I can see right here an area, a smaller part of this rectangle that has a length of 10 and a width of 10. Okay. So I see that. Okay. So let's record that. All right. So first, just to recap, we decompose 15 as 10 and 5. and I'm multiplying that to 12, and I decompose 12 as 10 and 2. Okay, so what I'm seeing right now is a 10 by 10 area, 10 groups of 10. And that makes sense because I know that my answer or total number of cookies will be greater than 150. Okay, let's look at another partial product or area of this rectangle. Okay, I see 5, a length of 5 here. And then again, there's a width of 10. So 5 groups of 10 would be 50. So I can fit 50 in this area. Okay. I'm going to jot that down. Okay. So I have figured out 10 groups of 10 and 5 groups of 10. I've basically multiplied 15 by the 10 in the factor 12. Okay. Now I'm going to multiply this all of 15 by 2. So I'm going to do that though with partial products. So let's see, 10, a length of 10 times 2 would give me 20. Okay. So 2 groups of 10 is 20. All right. I've got 10 2 times. All right. And I've got one more area here. There is again a length of 5 and a width of 2. So 5 groups of 2 or 2 groups of 5 is 10. So I'm going to fit these in here. All right, so notice in this area model, if I was to squeeze all of these hundreds, tens, and ones together, they would make a complete rectangle with no gaps or overlaps, right? You can see, and I've got them spread out so you can see them here, but you can see there's a row of 15 and another row of 15 and so on. There are 12 rows with 15 in a row. And then vertically, you can see, groups of 12. So there's 12 and 12 and 12, and you can see 12 is repeated 15 times vertically. All right. So thinking about this, if we compose or add together each of these, what we call partial products, they are part of the product that makes the total product. If we compose all these products together, it will help us find our total. All right. So we're going to first add these partial products together. So we had 100. So 10 groups of 10 was 100. 5 groups of 10 was 50. 2 groups of 10 was 20. And 5 groups of 2, or 2 groups of 5 was 10. All right, so when I add those partial products together, I can see 50 and 20 is 70, plus 10 more is 80. And when I add 80 to 100, I solve the solution 180. So this tells me there are 180 cookies at the bakery. Okay. Now, as students develop a stronger understanding of area models, building them and understanding how they function concretely, they can move to a more pictorial representation. All right. The work is really the same for the pictorial. We're going to draw the same representation over here. Okay. So again, I have a rectangle. We're going to multiply the two factors, 15 and 12. 15 will represent the length of the rectangle. 12 will represent the width. And I know that when I multiply the length times the width of a rectangle, I can find the product or the area of this rectangle. Okay, so just like we did in the concrete model, we will decompose 15 as 10 and 5, and we'll decompose 12 as 10 and 2. And I'm decomposing the numbers by place value so I can multiply these two-digit numbers into smaller parts, all right? So let's draw a line partitioning 10 and 5, and then I'm going to draw a line horizontally partitioning 10 and 2. All right, and you can see there are 4 smaller parts in this area. Okay, you can see this 10 by 10 area right here. You can see this 5 by 10 area. All right, so this would be a 10 and a 2. So this is a rectangle, so it's the same length on each side. Opposite sides are the same length. So 10 and 5. All right. So I see a 5 by 10 rectangle. I see a 2 by 10 rectangle and a 2 by 5. So this representation is really matching this concrete model, right? So from here, I can say 10 times 10 is equal to 100. And I'm multiplying the value of the digit 5 by the value of the digit 10 and 12. Sorry. Yeah, to get 50. Okay. Then 10 times 2. So 10 times 2 is 20, 2 groups of 10. And 5 times 2 is 10. All right. So I'm multiplying the value of each digit in 15 by the value of each digit in 12. Finding those partial products, we add them together to find our total product or solution, which was 180 cookies. All right. So today we looked at how to multiply a 2-digit number by a 2-digit number using concrete-based 10 blocks in an area model, and then transitioning that to a pictorial model.
I'm going to model solving a problem for IOA 2E. This IOA asks students to solve the 4 operations with whole numbers to solve authentic multi-step mathematical problems. Additionally, students should represent and model problems using equations and diagrams with a variable for the unknown quantity. Problems may also include solutions in which remainders must be interpreted. The problem we are solving is Rob is preparing for the school dance, and he bought 27 packs of cups. There are 12 cups in each pack. If Rob puts the same number of cups on 6 different tables, how many cups will be on each table? I will model this problem representationally. In the representational phase, students should construct models to solve a multi-step word problem. The types of models I will be constructing today are area models. Let's take a look at how this might look. So first, when reading the problem, I notice that my first step is to determine how many cups he has purchased. So my equation to represent this is going to be 27 cups times 12 cups per pack. And that's going to equal T, or my total number of cups. All right. So my equation would be 27 times 12 equals T. Now I'm going to solve this using my area model. I'm going to decompose 27 into 20 plus 7. And then 12, I'm decomposing to 10 plus 2. Now, before I go and solve this, I'm going to use my estimation to help me make sure my answer is going to be in the ballpark. So when I look at this, I see this as it's pretty close to 30 times 10. So for my estimate, I know that 30 times 10 is 300. So when I get my answer to this, it should be around 300. We want students to be able to use reasonableness to try and determine if their answer is correct or not. So now, looking back at my area model, I'm going to solve 20 times 10, which is 200. I'm going to do 7 times 10, which is 70. I'm going to do 20 times 2, which equals 40. And I'm going to do 7 times 2, which equals 14. Now I'm going to add my partial products. 200, 70, 40, and 14. And when I add that, I get 324 cups as my product. And you can see that's close to our estimate of 300. So now I've done my first step. Now it's time for my second step. So my next step is to solve this problem is to determine how many cups will be on each of the 6 remaining tables if Rob puts the same number of cups on each table. So to do this, I'm going to be solving 324 cups that we found in step 1 divided by the 6 tables. And that's going to be filling in for C, which is the number of cups on each table. So our unknown is C, or the number of cups on each table. So that equation would be 324 divided by 6 equals C. And when we think about this, we could also think about our inverse operation as well. So we could say 6 times C equals 324. Remember, we want students to be able to use that inverse operation to really help them when they're solving division as well. So I'm going to solve this using an area model. So now thinking about that, I know that we're doing 324 divided by 6. So once again, we could even use estimation for this as well. So I'm thinking about, well, 324 divided by 6. I don't know if our students can do that as an estimate in their head, but we could say 300 divided by 6. Well, 300 divided by 6 would be 50. So our estimate is about 50. So our answer for this should be somewhere in the ballpark of 50. So now to do 324 divided by 6, I'm going to find my partial quotients. I know that 6 times 50 is 300. 324 minus 300 is 24. We're going to bring this 24 over. And now I know that 6 times something equals 24. Well, 6 times 4 equals 24. So now when I do 24 minus 24, I equal 0, and my remainder is 0. So now I need to add together 50 plus 4. And 50 plus 4 is 54, which that's going to be 54 cups per table. So the solution to our problem is 54 cups per table.
In mathematics, the emphasis is on reasoning and thinking about the quantities within mathematical context. Specific strategies for teaching and learning are not mandated by the Georgia Department of Education or assessed on state or federally mandated tests. Students may solve problems in different ways and have the flexibility to choose a mathematical strategy that allows them to make sense of and strategically solve problems using efficient methods that they are most comfortable with and that make sense to them. It is critical that teachers and parents remain partners to help each child grow to become a mathematically literate citizen. These standards preserve and affirm local control and flexibility.